Welcome to Ask and Learn.
Okay, so for question A, this is the graph I drew before the collision, okay? And this is the graph I drew after collision. And all this graph is based on XY coordinate here, okay? So after the collision, since the momentum was conserved, that means the rack will move along a direction, which is the direction that the green arrow point here, okay? And the rack here is the combination of car A and car B, okay? So if I use momentum to describe the motion, it should be something like this, which is the PIV is the initial momentum for car B, and PIA is the initial momentum for car A, and their final momentum should go along this direction here, okay, which is the blue line here, and PF is the final momentum, and the angle between car A and car B is 90 degrees. And for question B, well, in order to determine the speed of the rack, we need to determine the final momentum. And the final momentum is equal to the initial momentum of car A squared plus the initial momentum of the car B and then square, and then put the square root here, okay? And we know the initial momentum of car A is equal to ma times va, which is the mass of car A times the speed of car A, okay? And the initial momentum of car B is equal to the mass of car B times the speed of car B. So if we plug in back to the equation, we have PF is equal to square root MAVA squared plus MBVB squared. And we know the mass of the car is 875 kilograms. And the speed of the car is 15 meters per second. And the mass of the car is 1584 kilograms. And the speed of the car is 12 meters per second. So therefore, we have PF, which is the final momentum, is equal to square root 875 kilograms times 15 meters per second, and then square, and then plus 1584 kilograms times 12 meters per second, and then square. And this will give us the final momentum is about 23,099 kilogram times meter per second, okay? So since now we have the final momentum, then we can determine the speed of the rack. So we know the final momentum is equal to the mass of the rack, which is the total mass of the car, which is ma plus mv. So it's the total mass of the car A and car B, and then times the speed. Then we have v is equal to pf over ma plus mv. And this will give us, this will give us 23,099 kilogram times meter per second over 875 kilogram plus 1584 kilograms. And this will give us the speed about 9.4 meter per second. Okay? And in order to determine direction, we need to determine angle first. We know tangent theta, and theta is the angle. Okay? So tangent theta is equal to the momentum on the y-axis over the momentum on x-axis, which is the initial momentum of car A over the initial momentum on car B, which is equal to 875 kilograms times 15 meter per second, and then over 1584 kilograms times 12 meter per second. And this will give us the tangent theta is about 0.69. And then we have theta is equal to the inverse tangent function of 0.69, which is about 34.6 degree. Okay, so it's the let me show you the angle. Okay, so if this is the horizontal direction, that's the axis, and this should be the angle here. Theta is equal to 34.6 degree. Okay, it's moving like this. So it's in a direction of angle with 34.6 degree between the horizontal direction. Okay, so it's moving like this. And for question C, well, in order to determine the distance, let's say s, and we know the distance can be equal to the final speed square minus the initial speed square over 2 times acceleration. And the final speed in this case is 0 because the rack will eventually stop due to friction. And the initial speed should be the speed we just figured out, which is 9.4 meters per second. So it seems like in order to determine the distance, we need to determine the acceleration of the rack first. Well, we know the net force of the rack, let's say F net, okay, is equal to the mass of the rack, which is the total mass of two cars, ma plus mb, and then times the acceleration is equal to 0 minus friction, okay, because only friction was acting on it, and what friction was doing is opposing the motion, so it should be negative, which is equal to negative f, which is equal to negative mu n, okay. Mu is the coefficient of the kinetic friction, and the n is the normal force from the ground. And the normal force from the ground is equal to the gravity of the rack, which is the gravity of the car A and car B together, okay, which is equal to ma plus mb times g. It's because the net force on vertical direction is 0 because the car didn't bounce around. You always stay on the ground, okay? So therefore, we also know that mu is equal to 0.55, okay? The coefficient of kinetic friction is given at 0.55. So if we plugging back this equation here, back into the equation here, we'll have net force of the rack ma plus mb, and then times a is equal to negative mu ma plus mb times g, okay? Then we can move the ma plus mb to the right side. We'll have a is equal to negative mu ma plus mb times g over ma plus mb. And as you can tell, ma plus mb can be cancelled out. Therefore, the acceleration a is equal to negative mu g, which is equal to negative 0.55 times the acceleration of gravity, which is 9.8 meters per second, and then square. And this will give us the acceleration is about negative 5.39 meter per second square. Okay, so the distance s will be equal to is v final square minus vi square over 2a, which can be equal to 0 square minus 9.4 meter per second square, and then over 2 times negative 5.39 meter per second square, okay? And this will give us the distance is about 8.2 meter. And these are the answers for this question. Thank you.